Good morning, everyone. My name is Lucas Costa, and I'm going to present about the paper Simpson's Paradox in Psychological Science, a Practical Guide for the class of Causal Inference. This article has four authors, as you can see here in the first page. To start with, I would like to divide this presentation in four stages. In the first one, you're going to discuss what is the Simpson's paradox and the importance of analyzing it in psychological science. In the second part, we're going to discuss how Simpson's paradox is addressed in this paper. Also, you're going to discuss about the key findings and contributions of the article. And finally, I'm going to do my evaluation and conclusion about this work. Well, to start with, what is the Simpson's paradox and what is its importance to analyzing psychological science? Well, as we discussed in one of our first classes of causal inference, Simpson's paradox occurs when a relationship observed in a group level is reversed when the data is divided into subgroups. So this leads to misleading conclusion about the behavior that you're trying to analyze. So we have the classical example of the Berkeley graduate admission that we discussed during the class, that overall we could see a bias, like we could think that there was a bias against women when compared with men. But when we saw the data into the subgroups by courses, we saw the first was reversed. Actually, like women were applying to courses were harder to get in. So, like, what is the relevance for this for causal inference? Is exactly this, because this phenomenon demonstrates the risk of drawing conclusions, causal inference from observational studies without careful subgroup analysis, and this is essential in many different fields. So, social science, as in this case, medicine, psychology. Also, being specific here about the important psychological science, like you can have the same problem of uh, drawing wrong conclusions based on the aggregated data instead of analyzing subgroup or individual data. This article delves deeper into some of those examples. So, for instance, one case is related to drugs to treat depression. So we can see like the aggregated data shows that the if you use the drug, if you use more the drug, you're gonna have improvement in your depression. But if you see this data disaggregated, we can see that this effect is bigger for people with like severe case of depression, but for the group of people with mild depression, the effect is not seen. So like this is one example in psychological science. And also in this article, we are gonna discuss like how to address how better understanding and addressing Simpson's paradox is crucial for improving the robustness and reliability of findings in psychology. Well, here we have two examples on top of the other one that I told you that were discussed in the article. The first one is more to describe like what's the Simpsons paradox. Basically, like you have one person that submitted, like have person A and person B that submitted articles to be approved in 2010 and 2011, and those people are being compared to decide who is gonna be the professor for a certain university. So if you look to the aggregated data, we see that the person A has 60% of approval, while the person B has only 40%. And we could conclude that person A is more qualified than person B. But if we see the data by years, we see that for both years, person B had a higher acceptance rate for the articles. So the only problem is that like although the person B had 100% in 2011, it submitted way less articles than the person A. And like on the right, we have a more interesting example, in my opinion. in which we can see how the recovery probability changes with the dosage of a medicine. So if you like with the aggregated data, we would conclude that higher the dosage, the higher the recovery probability. But if we segment these observations by gender, male and female, we see that for each of those categories, the effect is the inverse. The higher the dosage, the smaller the recovery probability. So this is a very good example of Simpson's paradox that were approached in the article. So like going deeper here, like how they are addressing this paradox in the article. Uh, well, this paradox has been like formally analyzed by mathematicians and statisticians, but we don't have many discussions about the practical aspects of it. So that's one of the goals of this article. Also, like how we should like once you face this problem, how should we deal with that? So the article also has some tools that we're going to discuss later about it. And the authors also argue that Simpson's paradox occur more often than we think, and inadequate attention to this paradox may result in correct inference that may compromise not only your conclusions, but also may create wrong policies, wrong decision making. Well, talking about uh, like the consequence of not addressing the Simpsons paradox. Going back to that example that we just discussed, like we can see that like with the wrong conclusions, we can we can take the wrong decisions because we can have two types of mistakes that we can execute when dealing with this type of problem. One, like it's related to the magnitude. So, for instance, the magnitude that like we are seeing the aggregated level, it's kind of different from the different groups, but different in magnitude. So, like both effects are positive, but when you aggregate it, we can kind of have the weighted average of that, but both are positive. But the main problem can be like when you have a positive and a negative effect. So this can completely change your decision process, and this can have like uh, a dramatic consequence in public policy, for instance. And one clear example of this is this one that we just discussed, that the effect in the aggregated level is positive for higher the dosage, higher recovery, but in for each gender, the effect is the inverse. So our decision here should be having a lower dosage instead of a higher dosage. So we have completely different actions, decisions that we can make if you only look for the aggregated level data or if you look at segmented by gender. Mhm. Following here, like it's very interesting how the article approaches to address the Simpsons paradox in psychological science. So when discussing about how to address it, it talks about the challenges to address it and the strategy itself. About the challenges. Like the main challenge here is that there is no single mathematical property that all instances of Simpson's paradox have in common. So you don't have one size fits all solution for this problem. And for that, we need to execute different analysis in order to address it. And one very interesting point of the article is to bring strategies to address this problem in different phases of the research process. So it has an approach when you're in the phase of prevention, so before you collect your data, but if you already have the data, like okay, like you're just analyzing it after, it has some strategies of how to diagnose the problem and how to treat it. And in this third part of the presentation, you're going to go deeper in those aspects with the key findings and contributions. Because basically, the key contribution of this article is in detailing strategies to address the Simpsons paradox in different phases of the research process. So in the preventing, the diagnosing, and the treatment. Going one by one. In the part of preventing the Simpsons paradox, here it's very interesting that the article says like, okay, before collecting the data, what we can do to prevent this type of problem. And it brought to us like three main points, which were basically like we should develop and test mechanism explanation. So here it's basically should think like which hypothesis do you have that the data in a certain level may be different from the aggregated level, and you make sure that we collect the data at that level. So for instance, if we imagine that we may have some bias, like we can have different behaviors for men and women, we should have this data. Or if we think that the results may differ by age, we should, in the data collection phase, make sure that we have the age of each of the participants so we can segregate the analysis after. Another approach is related to make changes to the study. So, and the main one in psychological studies is that usually we collect snapshots in a given moment of time of different people. And the article discusses how important would it be to collect data for specific individuals along the time. So this can create way more robustness to our conclusions when generalizing this problem. And finally, it suggests how to intervene. Here it's basically how to do experiments. So basically like kind of A/B tests to understand the phenomenon that we want. So if you have the possibility of doing this, we do it. So like if you have hypothesis that the behavior may be different for one individual, we analyze the difference before having the treatment and after having the treatment. The second part discuss how to diagnose, how to work when diagnosing Simpson's paradox. So like, okay, you already collect the data. What should we do? Uh, Here the article discuss like four steps. The first one is to visualize the data. So it's extremely important that we not only analyze the p-values, the statistical summaries, but that we see the data. You plot the data, but also like says that like okay, we can not only plot, but we need to analyze also like if like this the segmented data has statistical significance, the data there. Another point is the condition independence. So here it's basically like the approach that we discussed in the Berkeley graduate admission case article. So like how to analyze by like the different segments. The homoscadic residual analysis, like this one is very interesting. That's basically like says that we should analyze the residuals of our plots because like if you have a high residue, like because the residuals should be homogeneous in your regression. And if we have like some dispersion of the residual, we should like check for that part of the data what's happening because it can be indicative of the Simpson's paradox. And finally, discuss about clustering. So, okay, we have our aggregated data. How we can create clusters of this aggregated data, and in order to understand if those different clusters have different behaviors. And here, like we have like more obvious clusters since men and women, but the article also brings some like interesting insights related to clustering that I'm gonna discuss later. The third part is treatment. So like here in the part of the treatment talks basically like about the importance of identifying those clusters, those segments that may have different behaviors. And once you have those clusters, how like you should do the analysis to understand if the difference between the clusters are statistically significant or not, to understand if your conclusion, the aggregated level, is different from your conclusion from this the segmented data. And basically, the authors of this article developed a tool in R to analyze and treat the data. And I'm going to talk more about this tool, which is very interesting. I gave a look at it. I'm gonna like for sure I'm gonna use it. It's like it seems very robust and like interesting because basically this is a tool that they developed in R that can be used to detect Simpson's paradox cases in for bivariant continuous data. And it was developed to be specifically to be easy to use for psychologists. Like this tool has several benefits. And the main three ones are like it's reading in R. So like it's a language that usually researchers are using. So it's easier to integrate with the other workflows. Second, it's specializing in detecting the case of Simpson's paradox for bivariate continuous data with categorical grouping variables, which are very common inference type for psychologists. And finally, it's open source. So like if you want edit it and like incorporate something into the model, you can do that. And how this tool works. So basically, it estimator like it analyzes to see if you can find if you can find clusters in your data. And once it identify those clusters, it's gonna run regressions for the different clusters, and then it's gonna compare the results of those regressions with with the regression that you have with the aggregated data, and analyze if the difference between those regressions are statistically significant or not. So like this is a very interesting approach. And on the right, we can see one example of that I was talking about the clusterization. Because basically we can see in like basically this graphic is describing the performance of a tennis player as a function of its arousal. And in the aggregated data, you see basically no correlation between the two variables, like it's slightly negative, but basically like no correlation. But when you do the right clusterization here, which is they took the data of like a lot of different data about the players and created two clusters. One they call like aggressive players and the other defensive players. So based on their statistics, they classified the players on those two categories, and they could see that the performance varies for the two groups. So like for the aggressive players, they higher the arousal, they higher the performance. For the defensive players is the opposite. So you can see that our aggregated conclusion is different for each of those clusters that we created. And this can lead to different decision makings. I really like this example. But now, finalizing our study here, going to the part of the evaluation conclusion. As I already told, I really like this study, especially this 2 in R. I think the main strength of this article is to provide this tool to detect the Simpsons paradox in different data sets. And also it provided me with a clear comprehensive review of the Simpsons paradox. So I could go even deeper in relation to what we discussed in the class. I believe that the main weakness is that I was expecting to have more real-world examples in psychological studies. We had some, but I was expecting to see more. And for me, the main novelty and significance is exactly providing mental frameworks of when you see a data set, when you see some conclusions, how to think if the conclusion in some parts, in some segments of the data may be different. So equipping me with some mental framework to think about it. And also the tooling are that extremely helpful. And this can be generalized not only to psychological studies, but also to different fields, public health, education, policy research. So finally, all in all, the conclusion, I think in the last slide I already approached a lot about it, but mainly this paper provided me with very interesting frameworks to approach this type of problem, also made me a lot more aware about the importance of visualizing the data, to understand those patterns, and to pay special attention always when you see general conclusions in any type of analysis. So thank you very much for checking it. And yeah, thank you.